Okay, hey there guys, and welcome to this video on addition polymers. Right, so you need to know exactly what an addition polymer is. You need to understand that addition polymerization can only occur between molecules with a carbon-carbon double bond, right? That is how they happen. You also need to recall that in addition polymerization, there is only one product, which is your polymer. You don't actually produce anything else, and we'll have a look at plenty of examples of that. So let's dive straight in and have a look. Okie doke. So basically, a carbon-carbon double bond occurs in organic molecules known as alkenes. If you don't know what an alkene is, then go and have a look at my video on those, because you do need to know what those are. Now, the alkenes have this carbon-carbon double bond, and basically what you're going to do in a polymerization is break one of those bonds, right? So not the whole double bond, but you break open one of those bonds. Reason being, remember that carbon always has 4 bonds, and now it only has 3. So if you break that open, each carbon can now bond to something else, and this forms a chain. And so generally what we're going to do is you would then draw the bonds like this, and it just makes it nice and easy to look at. You know, in reality, these are in 3D, but this is just a nice way to draw it. And so this can now bond to the next molecule, right? And this forms a massive long chain. And so in summary, this is what you get, right? If you have n number of these alkenes and you break this here bond, then you form a chain which consists of n numbers of this unit, right? This is the way we show the polymer. Now this is actually your repeat unit. Okay, if you're asked to draw your repeat unit, by the way, then you draw it like this without the brackets. This is your repeat unit because this comes from your monomer, which is the alkene, okay, and it repeats itself. If you are asked to draw the polymer, then you put the brackets in, okay, and bear in mind that the bonds extend outside the brackets like so. I'll just go over them. And then you put n because there are n numbers of those in your molecule, right? N can stand for any number. Some polymers are like thousands of carbons long, and so N could be anything, right? Okay, so let's have a look at a couple of examples. Right, so it doesn't have to just be an alkene. It could be any alkene derivative or anything with a carbon-carbon double bond, right? And you can always add across those carbons. So basically, if you've got chloroethene, right, you swap one of your hydrogens for a chlorine, okay, you form polychloroethene, which looks like this on the right. So you've still got that chlorine attached to each one of these carbons, right? Each one of these carbons on the left, that is. And this just repeats itself, right? And this is called polychloroethene, or PVC for short, which is a plastic that you've probably heard of, which is used in the linings on the outside of windows. Okay, and so that is basically how it works. By the way, let me just take this into a bit more detail. When we name our alkenes, right, I'm going to go back over here to our last one, right? This alkene is called ethene. You should know that because you know the names of the first 4. So this is ethene. And so when you join them together, the name of the polymer is quite simply, poly, open brackets, and then you name the monomer, right? And the monomer is ethene. Okay, so this is polyethene, right? Or polythene for short, and that's what we use to make plastic bags. And so with chloroethene, you end up with polychloroethene. Surprise, surprise. All right, now let's have a look at a quick example question, because there is a knack to figuring out how to draw the polymer. So draw the polymer polypropene, and this is the method I want you to always use. When you're asked to draw a polymer, draw the monomer first, right? It's going to help you. So polypropene means that propene is the monomer. So I'm going to draw it, and I'm going to draw it in full. So propene has 3 carbons, because prop means 3, and there is 1 double bond. And so this has hydrogen, hydrogen. It's going to help you, by the way, to draw your bonds vertically rather than diagonally, because that's how you're going to draw them in the polymer. Okay, so this is propene. Now the problem here that people have is they end up saying, okay, well now this carbon is going to join to the next one, and this carbon is going to join to the next one, and that's it. Well, that's wrong, because you haven't broken the double bond there, right? the addition happens across the double bond. And so what we do is anything that's bound to these two carbons, these two, right? Because those are involved in the double bond. Anything else that's bound to those, we write in shorthand to make it way easier for ourselves. So what I'm going to do is I'm actually going to say, well, what's bound to this carbon, right? Let's rub these bonds out because they're obviously wrong, right? That's what I said. So this carbon is bound to two hydrogens, and so that's fine. Well, this carbon here is bound to a hydrogen, that's fine. But it's also bound to a carbon and three hydrogens. So 1, 2, 3, like that. Yeah? So, what does that mean? Well, how do I write that? If I'm going to write that in shorthand, I could just say that is one carbon and three hydrogens, so it's CH3. And so, to get it out the way, I'm going to shorthand it down here and say that is CH3. Right? This is exactly the same molecule, except now it looks like what it looked like before. Okay, so here it looks like this, without the actual polymer drawn yet. Okay, but that's what we're going to do now. So it looks exactly the same, except like this hydrogen, for example, would be replaced with a CH3. And so that's what I'm going to do. If I have N lots of these, okay, then it forms, break the double bond, so carbon, single carbon, and then just draw what's around it. CH3. And now you can see that these carbons can now bond to other things. And that is exactly correct. And there are N lots of those. So don't let it fool you when you have something which is more than two carbons long, right? The only thing you focus on are the two carbons in the double bond. And that is how that is done. So let's have a look at another few examples of addition polymers, just so you can get an idea for what they're going to look like. Boom. So this first one, you've got 4 fluorines, right? That's actually polytetrafluoroethene. Okay, so you've got 4 fluorines around the 2 carbons in the middle. This is the one that we just saw. Okay, this one here is the one we just saw. That's actually polypropene because 1 carbon, 2 carbon, and then you've got the CH3 bound to it. Okay, down here, you can see you've got way more carbons. Yeah, but we've still focused on the 2 carbons which had the double bond, and then we've just written the rest of the carbons as like a side chain. Okay, so that's fine. And then finally, this one is of course polyethene, and that is something we've seen before. Okay, so I'm going to stop there. I hope that made sense. There is a trick to it. Make sure that you follow that procedure. Make sure you hone in on the 2 carbons which have the double bond in between them, and then you draw the polymer based on that and draw everything else as side chains around those 2 carbons. I hope that helped. If you do have any questions, feel free to pop them in the box below or send me an email. I'll get back to you. But as usual, please do like and subscribe as usual because it does really help me out. But thank you so much for watching. I'll see you in the next one.